Find the average for this set of numbers. You guys got calculators, so do it. Find our mean. This is page 77. Check it again, because that's not right. Still not right. Add them all up. And divide by how many? So when we add them all up, what do we get?
410.
410. Oop, that's not how we write a 1. And we're going to divide by 10. So our average is? So what's our average? 41. Bless you. I think you missed the 10. So slow down and pay attention to what we do. All right, so then let's find our median. How do I find our median?
It's the middle number, right?
It's the middlest number.
We don't have one since it's 5 on the top.
So it's going to be halfway between what two values? 30 and 50. So our median's right in here. What is exactly halfway between 30 and 50? 40. So if you have a median between two values, you average them, those two specific values. So it's our halfway point or midpoint. So this one is between 30 and 50, which makes it 40. So our mean is 41 and our median is 40. So they're pretty close together. But what if we have a typo in the data? What if there is a mistake or I just have one really out-of-pocket answer? Like, so we're going to look at the next data set and say, what if that 80 wasn't an 80? What if that 80 was an 800? What would happen to the mean? What would happen to the median? So everything else is the same except for that last number. So what is our new mean and what is our new median? So when we're finding our mean, we wound up with what? 113 is what I have too.
113, yeah, that's what I got. Where are you getting 110 from? Moses, where are you getting 110 from?
That would be that you missed a 20 somewhere, but 20 is not one of the values, so you just dropped one?
Oh, that was right.
Yes. I'm off by 3.
I was like, if you got 110, that means you were off by. Oh no, you were off by 30. And the average. So you dropped one of the double 30s. You didn't hit both 30s in.
You didn't do both 30s?
Oh, I didn't do both 30s?
Yeah, you missed the double 30. That's what it was. So what is our median with this new data set?
It is still the same.
It is still the same. It is still halfway between 30 and 50, so it's still going to be 40. So just by replacing the 80 with an 800, what effect did that have on our median?
No.
Median didn't change at all. What happened to our mean?
It changed by 3. The value is 30 off.
Whoa, it changed by what?
Oh, I'm slow. Oh my god. I mean, it changed by a lot.
It changed by a lot.
Sorry.
Big change.
You said what? You said wrong hallway.
So this is when we get that, when we were talking about the data shapes, when we have that distracted boyfriend, the distracted boyfriend meme, where the mean follows an outlier. So if we have one outlier, it can pull our mean, our average, really far away from where the center is. Because the true center should be somewhere around 40. Most of our data points are down there in the 20, 30, 40, 50, 60 range. We just have this one weirdo up in the 800, so our average has been pulled up really, really far. It's above most of our data. So when we have things that are big and weird like this, when we have outliers, we actually don't use our mean and our standard deviation to measure things like our center and measure our spread. That's when we're going to use those box and whisker plots. We talked about those at the very beginning. And that's what we're really going to focus on today, is we're going to figure out how I figure out exactly what is an outlier and how we make those box and whisker plots. And that's what we're going to do on the next page, which is page 78. And I have the whole of page 78 right here. It's going to make it a little small on the screen, but we're going to do the whole page. And we're going to start with number 1, and we'll come back to the line at the top at the end. So I'm going to zoom this in just a little bit. All right. So what we're asked to figure out is it's something called a 5-number summary. And what we're going to start with is we're going to start with our minimum, our maximum, and our median. So for all 3 of those things, it's really going to be helpful if we have them in order. So the first step, whenever we're making a 5-number summary, if we're going to make it by hand, we got to put them in order. So we're going to put these in order. We're going to have our 14, and then our 32. There it is. 39. Another 39. 51. Oh, come on. 53. 55. I'm running out of space. 61. Oh, I've only got one left. I can fit it. There we go. And then 90. There we go.
Somebody said it looks pink.
It is pink. It is pink.
So at first it's purple, then it's red, now it's pink.
It's hot right now. It's hot.
Hot pink.
Like dark pink.
Mm-hmm.
It's not purple.
That's my timer. I go use the fun.
All right. So now my question is, what is our minimum?
Oh, you're all the way off.
Yeah, please have a rich.
No, at first it was
All right.
red.
We're not talking hair color right now.
Because I put purple and then blue because of how it is. I washed it right here, it all faded.
What's our minimum, guys?
What I wanted, but because I also like this, to get like
All right.
outer layers, it drips down.
Save that conversation for later because I really cannot yell over you. It hurts.
For us or
Yes. Yes.
Thank you.
Both. Guys, it really hurts for me to yell over you. Please stop. Looking for our minimum. What is the smallest value? 14. I can't hear you when there's 6 other conversations happening. So you got to say it louder. What is our maximum? I heard that one even though you whispered it to be sarcastic. What is our median? Yeah. I'm gonna give them a second to think about it because they're not listening. But yes, you're right. It is in the middle. 45. Whenever I'm finding these by hand, I'm going to circle my median. 45. Because what we're going to do now, we're going to find the box that goes in the box and whisker plot. And what that does is it takes the pieces on either side of my median and does the median again. So I'm going to look at this side of my median, and we're going to find the median of that piece. What is the median of the numbers that are smaller? 36. That is called my lower quartile, or LQ, or Q1. That's 36. Then we're going to do the same thing with the bigger numbers. I'm going to take my numbers bigger than my median, and we're going to find the median again up there. 55. That is my upper quartile, or Q3. So when we're looking at a box and whisker plot, what we have is we put our minimum on one side, our maximum on the other, so it was 90, and they get connected with a line. We have our 36. Ideally, these would be like to scale, but I'm doing it by hand and we're kind of eyeballing it. And we have our 55, which is going to be a little bit more right there. So I'm working from the outside in here. And what these two pieces do is they make that box that we've seen. And I tend to color my box in just a little bit because it's a little easier to see when we have a little shading on it. And then our last piece is to put our median in here. Ooh, I love that squeak. That was fun. And it's 45. So when we have this kind of data, we can make these box and whisker plots. And again, ideally these would be to scale so that we can like see what's actually happening and where things are. But this lets us visually see kind of where everything is and where things get broken down. So the other thing that box and whisker plots let us do is they actually let us figure out exactly where something becomes an outlier versus not an outlier. And what it is, it feels really arbitrary, but I promise there's reasons for it. It's actually when we find how wide the box is, that number is called our inner quartile range. So I want to know how far apart my pink and my blue lines are. How far apart is 36 from 55? How far apart are they? Yeah, it's literally the width of the box. It's how many spaces? 55 minus 36. So we subtract them. That is called the inner quartile range. 55, and we're going to minus our 36. So our inner quartile range is 19. And the way we determine if something is an outlier or not is if it's 1.5 boxes away from the box. So it's 1.5 times the IQR. So that's going to be the first thing I figure out is what is 1.5 times our 19. What is 1.5 times 19? 28.5. So then what we're going to do, the barrier that decides where if we have an outlier or if we don't, is I'm going to say, if I go 28.5 this direction from my Q1, do we have any values? So we check our 36, our Q1, And we're going to take away that 28.5. That is a trash 8. We're going to fix that. There we go. 28.5. Yeah. Do we have any data points that are smaller than 7.5? No. So since we do not have any data points smaller than 7.5, we have no small outliers. Then we're going to check the other direction. Let's see if we have any big outliers. Do I have anything that is less than, or that is more than 1.5 IQR from this box? So we're going to take our Q3, we're going to take that 55, and we're going to add that 28.5. Mm-hmm. Say it again. You multiplied. Add. 83.5. So you went way big. Do we have any data points that are bigger than 83.5? 90. So 90 is outside of the kind of window that we see that would be kind of valid data. So what that means is 90 is an outlier. It is too far away from our median, from our quartiles, in order for it to count in kind of the regular data set. So 90 is an outlier. It technically makes our data set skew. And there are ways that we can do this in CodeApp and see this same information without even needing to do all of it by hand, but I want us to do it by hand first because I mean like that. Because all this is checking for and seeing how we can find out about outliers. That's what the focus of this is. So an outlier is a data point that is more than 1.5 times the inner quartile range from either the upper or lower quartile. And I'm going to show you how we can see this stuff in CodeApp because we're going to look at that for several of other pieces and why we do that. So I actually have this entire data set in CodeApp that I'm going to show you how we can do this. I'm going to do that. There we go. The what? Let's do the hands to ourselves, y'all. All right, we're going to zoom it in. This is the exact data set, and I did not even sort, like I didn't even take the sorted one and put it in order. All right, I'm just going to make this a little bit smaller. There we go. So I'm going to grab our data set, and I'm going to put it in the graph. Just like we've done before. I could come here, I could mark my mean, I could label it, and I could have them show our standard deviation. Like, those are things we've done a bunch of times so far. It's all well and good, but we know we have this one piece that's our outlier. So instead of showing my standard deviation and my mean, I would love to show my median. And then I'm going to come down here to where it says box plot and normal curve, and we're going to click box plot. And it'll make it for us. And if I even put my mouse over it, it shows here my lower, my minimum is 14. If I go to the box, it's got my quartile 1 of 37.5. Did I type something in wrong? Oh, I didn't hit the double 30 legs. My data's a little off. What did I miss? 36, 39, 90, 55. Oh, I have too many data points.
You have 60 up
I do. How do I have 11 data points? 39, 51, 36, 39, 90,
You're missing 16.
55, 32, 61, 45, 53, 14. How am I missing? I'm not missing any of them. Why are my values different? Their median should be 45. Hey. Our upper, they've got it as 54. 90. Well, I've never had them do this with a data set before. Fun times. I don't know why they're calculating it differently than me, but we've done the same thing. What's really cool about CodeApp is you can come in here to our ruler, and you can actually tell them to show outliers, and it'll show you that 90 is an outlier. It does the test for you. What they're trying to do and what we're seeing. Hang on, I gotta do this where I can actually read the words. I don't like this. There we go. Okay, no. I don't want those. There we go. So what this shows us is it shows us this outlier of 90. I was trying to get it to do a thing, but it wasn't letting us. So it missed a thing on me, but that's okay. So this will show us that same information. And if we hover over it, they calculate their stuff a little bit differently. I think they do the a slightly more accurate version of like stats version. But what we do gets the job done. Okay, so we can use CodeApp to help calculate those things for us. We don't have to do it by hand, but when it's a small data set, we can. The downside of doing things by hand is sometimes our data sets are not very pretty. Because the one we're going to practice with next that we're going to look at is this one. And it's the next page, I think. Nope, it's not. It's on the other side of hurricanes. Sorry. I'll get your page number. Where the heck is this one for y'all? I know it is before hurricanes. Where the heck is it? Oh, it's not in your book. I love that. Okay, I don't have this one in your book.
Yippee!
We're still gonna look at it.
Yay! On the one on the board?
This one on the board. Because I haven't done it for like 2 years, so I took it out of the book, but then we have the software, so now we can do it. And then, All right, so looking at this data set, this is how far in light years these particular objects are from the planet in general. So we want to calculate the mean and the median for these, which, come on screen. Looking at this data set would be obnoxious to do by hand. There's way too many zeros. So what I'm going to do is I'm going to use CodeApp, and I actually have this data set already set in here. There we go. Let me get it in here. And I actually have it in the Canvas page if you want to do it too, but you don't have to. We're mostly going to talk about it. So if I want to look at this data set, all right, gentlemen, please stop. I've already started working on a seating chart to change things. If I finish it, I will instigate it. The more times y'all talk over me, the more I will work on it. And once I have it right, I will put it in place.
Where am I sitting?
Somewhere else. I would say all y'all got moved someplace different. And it's not next to any of your buddies.
Even me?
Most people got moved at least a little. But so it's like, it's still in progress. And if it
I mean, we work good together.
I know, and I do keep those things in mind. But I'm just saying, if it continues to be a problem, the more times I work on it, the more likely it is to get into place. All right, so here is our data set as it is. And this is all about our distance in light years from the planet. I need to make this a little bit shorter so we can actually see stuff. There we go. So what do we think is going to be our best way to measure this? Are we going to want to use our mean or are we going to use our median? Why?
I mean, look,
I'm not saying you're wrong, I'm just saying why.
you got a lot on zero.
We've got a lot on 0. And what is our one really big piece going to do? It's going to shift. It's going to shift what thing? What? Which one is going to shift because of an outlier? Which center moves? Not the median. The mean. Mean is our distracted boyfriend. The mean, so if I mark over here, if I put my mean and my median's actually at 0 light years because most of our data was decimal stuff. Like look at these data points, 0.004, 0. Blah, blah, blah. Most of our data points are 0, so our median is 0. I bet it's like a gross decimal, but they've rounded it. Our mean is actually 39 light years. So a long way outside the solar system. Because look at Saturn. Saturn is only 0.0014. Jupiter, they didn't go farther than that. They were afraid of apparently giving you guys planets further than that. I don't blame them. So when we come in here and do something like the box plot, if I don't have it show outliers, not that. It's really hard to see it from this angle. There we go. We've got this one little bitty box and a really long whisker over here. But if I have it mark outliers, that is going to pretty clearly show an outlier. And we actually have 2. So I want to get in so we can actually see this a little bit more. So what I'm going to do is I'm going to hit this case. I'm going to hide this one so that I can zoom in and we can see this a little bit more clearly. Even still, we still wind up with very little information and we can't really see much of our box and whisker plot because these are so close together. This one is still considered an outlier. Even though it was still pretty close, this is, I think, the nearest star to our solar system, the Sirius star. But it is also still so far away, it's considered an outlier outside of this data. So I have to get into our solar system before we can even see our box and whisker plot here. So our median's down over here, which means the center line of our box and whiskers right here. So this data is still skewed pretty far with this tail on the right. So this is very much a right skew data set. Even within our solar system, we still had an outlier from the things we looked at. So this had 3 outliers in this data set. Out of the, 9 items, 3 of them were outliers, just because of how close together the other pieces were. So we have a tool that we can use to test this, and we can use CodeApp to help show, show all cases, all these pieces out here. So we can show what is and show what is not outliers. We can mark where means and medians are. We can look at things in light years, and we can see those pieces of information. Okay? So, I have a lot of people that have not yet submitted their hurricane project from yesterday. I have received 10.
I don't know what you call it a project. It's like
Little baby project.
Fresh. Real fresh.
I'm gonna look at it. I was gonna say, okay, I do have 11 now. So the instructions on there, it will go in. I was like, I still need to talk with Miss Thede about it, but usually it goes into the assessment to kind of maybe give a boost to some of those test grades that some of us need a little boost on. So it goes in kind of like a quiz.
See, I was thinking.
I know, but we still need to catch up. That's part of the deal with field trips is that we do need to catch up on stuff.
Hey,
I caught up on all my work
Good.
already.
Good.
And I've been sitting
And
and doing.
so there's also a little bit more homework. We're gonna that homework 5, the data set for it, there is a link on CodeApp to it, but it is also in your workbooks on page 80. So homework 5 is pages 81 and 82 or Canvas, but I do recommend using the CodeApp file on Canvas, but it's the same questions. Yeah. Go ahead, Matthew.